small query. This is the curve. So there's a x and y axis we have chosen. So this is the x axis. This is the y axis. Then the straight line. Let me assume a straight line. So what is the straight line? Let it be y equal to 2x. What is the equation of the straight line? Y equal to 2x plus 3. So the equation of straight line is y equal to 2x plus 3. I'm writing that, okay, we'll use this fluorescent color. No. So look at this, y equal to 2x plus 3. Then, sir, like what is put x equal to 0? This will be 3. Then we'll choose some values, x equal to 1, 2, 3, 4, 5, 6, certain values here. Then corresponding to, you can go for tabular column as usual earlier, the graph, everything we can choose for various values of x, you'll get the different values of y. Let me ask myself a small question. I'm just picking up 2 strips here. I'm just picking up 2 points. So what are the position of that points? Let this be 4, let this be 6. This is x1, this is x2. Corresponding to that, we'll get y1. How to calculate y1 and y2? How to calculate y1 and y2? Here I'll use this one. y1 is given by 2 into x1 is 4 plus 3, 11. y2 equal to 2 into 6 plus 3, 12, 15. Okay, these are the values of y1 and y2. Now we have to find out the area of this shaded strip. Area of the strip has to be determined. So what we have to do? So what is the area of this particular shaded strip? Let me go for a smaller one. Okay, somehow we have managed. Okay, this area of the strip is needed. So it is like some sort of trapezium. I think everyone is aware of this. Sorry, it is trapezium. So we'll call A, B, C, D. This area is what needed for me. So it's very simple. Sir, we know it's a area of strip ABCD. What is the area of the strip ABCD? Half into height of the trapezium AB by 2. Sum of parallel sides AD and BD. AB is what? 6 minus 4 by 2. AD value AD will be 11. BC is how much? BC will be 15. So 26 centimeters square. Okay, this is the area of that particular strip. Okay, there is no problem. We are much comfortable, sir. We are very good in basic geometry. Area of the trapezium. Okay, till here, no problem. Like this, I think I'll just put once again. This is what the trapezium. This was the trapezium. What we're discussing, A, B, C, D. Some of you are asking, sir, like what is trapezium? I just shown a shape, a geometrical, like a surface of this particular shape is called as a trapezium. Okay, let's, our trouble starts now. Our trouble starts now. I will migrate to the next condition. So there's a curve. So let me introduce the y equal to x square graph is what I'll plot it. Already everyone knows this. Not a straight line. Okay, there is some sort of curve, I'll bring it. This is y, this is x. So what is this curve corresponding to y equal to x square? Now similarly, let me bring the same 4 and x. the same 4 and x is, let me bring it here. Very difficult to draw diagrams. Okay, this is the area of the strip. So what is value? X is equal to 4, x equal to 6. Correspondingly, we'll calculate. So if x equal to 4, y will be 16. If x equal to 6, it will be 36. Now this area under this curve is needed. This yellow color, this area has to be determined. Sir, okay, what is that? The similar thing you can, I will shift it. Okay, now you can see that clearly. Is it really a trapezium? No, we have a curvature here, no? We have a curvature here. So look at that curvature. It will do come like this. I'll draw a better one, no? Rather than fighting. So here the condition is like this. There it was not visible. This is the curvature. This area under the strip has to be determined. Can we find out? Next question comes. Can we find out this one? So is it trapezium? Next question comes. Is it trapezium? The answer is no, it's not a trapezium. It would have been trapezium. It would have been trapezium if it were like this. I'll still indicate with a no. So is it trapezium? So what we should call simply, it's not a trapezium. No question of now using that area of like area of that like a area of trapezium formula. Are you able to get this? Hope I'm. So actually, so you have this curved part. This dotted one. Sir, what is that curved part? You have put a dotted one. The dotted one will be of like this. No, now you can see this part. Have patience. Just I'm trying to. If you had this particular area to this yellow color one, then it will become a trapezium. But definitely it's not a trapezium. There's not a trapezium. How to find out this area? A million worth question. A million worth question, that one. So there should be some formula. So therefore now area under a straight line, very easy to calculate. Area under the curve, very difficult, because what is this? There's a curve. So very difficult to calculate area under the curve. That's the biggest headache what we have. Sir, any method? Yes, we have mathematics here. So we will do one thing. We will try our level best to get this solution for this. Level best to overcome this particular problem. So I'll propose like this. In the first case, Okay, I think everyone is able to see. In the first case, the curve is this was basically a curve, no? So we will let me, yeah, we'll start this one. So in this case, what I do is like, I will do some approximations. What is that approximation? So first I will add up this. Is it equivalent to that? Sir, how come? So this area, this total area, is it equal to area under the curve? No. Lot of errors there. No, this much is the additional area we are adding up. The primary in the first case is what I did. Like, so what I did, what I'm trying to do is like how to calculate area under the curve. We don't know. We don't have any formula. So therefore, so we will do like this. So can I take this area, this total area? Yes, there'll be a lot of error because this much of additional things is what we are adding. So why you are putting this dotted line? Because I'm very good in the area. I'm very good in the area of a square or area of rectangle. I can easily find out. I can easily find out the area of a square or area of rectangle. But what is this? A lot of error is there. Sir, why you are writing error? So here what I'm doing is like I'm trying to sample it. Means this is what area under the curve I say. So definitely it's a lot of error there. So further, what we do is like we'll further sample it. I'll decrease the step. I'll decrease the value of step. I'll decrease the value of step. You can see this. Now, okay, little bit fine. No, compared to previous one. And here what we do is like this is the step what we have picked up here. So earlier it was a very big step. So now it is delta x, width of the step. No. So I'll do one thing. I'll further decrease the width of the step. I'll further decrease it. Okay, look at this. Compared to previous one, I think this is okay, no? Compared to previous part. So what is the value of delta x? 3, you write it. Earlier, the delta x1 was very big. Earlier, the delta x1 was, in fact, very big here. If you want, I'll show it. This was the delta x, no? Lot of error, the delta x1. Now, if I add up, a steps of increasing height and width delta x3. So what do I get? I'll get the area which is near to the area under the curve, but still error. So what is here? Total area under steps is greater than equal to sum of total area under steps is greater than equal to area under the curve. This is what the comment is what we are going to write it. Total area, the sum of total area under the steps is greater than the area of curve. Now also the same thing. Very much greater you can put it. So now also, I think the same comment is what we are adding it here. So again, sir, will you add same comment in the third case also? Yes, it is to the third case. Sum of total area under the curve, the sum of total area under the steps is greater than the area under the curve. Okay, no, this is so, but definitely what you can see, what we can say in the first case, area under the step is very much greater than area under the step is what we'll write it AS. Area under the curve will write it AC, which is very much greater. So a little bit okay. Here also little bit the difference. No. Okay, come for this one. Shall I decrease further that step, the width of the step? So how much you are going to decrease, sir? I'm going to decrease it to a certain small value. So here is what that step will come. Okay, it has come to very small value. Delta x4, I'll write it. Then now definitely you can say that comparable, no, area, sum of the total area under the steps is comparable, not something greater. Comparable means almost not equal, almost nearer to it. Sum of total area under the steps is comparable. Is comparable to the area under the curve. So what I should do here, like I should make this as small as possible, no? So how much of small I'll make it? I'll bring here a very small one. So means as I make it, the width of the steps smaller and smaller. Then if I add up all such rectangular strips of very small width of a varying height, so what do finally I'll get? I'll make it equal to area under curve. So here what I'm going to do is in the next part, I'm going to bring a infinitesimal strip. Infinitesimal width. dy, okay, dx it is. Such strips, if I add, it has become very small. So for finally what we did, I think I can explain graphically very easily. Try to notice now. So it was like this, no? So here I'm going to decrease the width of the strip, and finally it will become infinitesimal width. Infinitesimal means it will become equal to dx. So earlier, the first case it was like this. Delta x1, then I decrease delta x2, delta x3, delta x4. Now the delta x tends to 0, it will become dx. So it is so small that even I should not, I cannot draw, I should not draw it. Okay, there's a dx now. So this is the same curve, y and x. Sir, how you find out? So now I'll find out this area of the strip dA equal to y dA. Such rectangular strips of increasing height, if I keep on add, what do I get? I'll get the total area under the curve. Able to make it out. So what is the methodology here is like we have to consider strips of increasing area. We have to consider strips of increasing we have to consider the strips of infinitesimal width of increasing height. If you take the sum of all that, you're going to get area under the curve. So how to add off that infinitesimal like a elemental strips? That is what the integral. That's what the integration. So what I'm going to do is I'm going to just integrate. I want the area under the curve. So area under the curve, this area is what needed for me. Not total area, at least I want this area. So how to calculate that area? So I'll just use a very simplified approach. What is very simplified approach? I'll bring in a strip like this. Then what is this? This is equal to dx. This is y. So this is A, this is B. First, I'll calculate the area of that infinitesimal strip. First, we'll calculate the area of that infinitesimal strip. Then what we do, we'll add up such strips of increasing height. Then we'll get the total area which is under the curve. So therefore, this is what I'll call it. The area under the curve, we'll call that as integral. So what is I is equal to here? Area of strip. Okay, I'll start our discussion with this one. So hope everyone is got the idea what is the meaning of integration, why we should integrate. There's the only reason. How to integrate is we will see now. Okay, now let's start our discussion. Hope everyone getting. So some just I shown some graphically things. We'll define the, what do you mean by integral? What do you mean by integral? Integral is sum of rectangles of infinitesimal width. So such things what we are going to add up here. So here what is that infinitesimal width? Once again, I'm bringing into the picture. This is dx, dy. This is the what that infinitesimal rectangular strip. Rectangle of infinitesimal width is what we are supposed to interpret in this way. By adding up this, by adding up the rectangles of width dx and increasing height, we'll get the area under the curve from A to B. The green color strip area we can find out. So how to express that is given by the formula I is equal to y into dx. You can write y into dA, A to B. This will be further y dx. Now what is y into dx? Y into dx is area. So such rectangles, when you keep on such rectangles, small rectangles of infinitesimal width, if you of increasing height, if you add up all, you are going to get the total area. The total area is nothing but the integral. So this like a definition, we'll put it like a f of x dx a to b. Now a and b are called as a limit. From where to where you want area, from x equal to a to x equal to b. That is what these are called as limits. So a is called as a lower limit, b is called as upper limit. Now, sir, what do you mean by these things still? So this is called as an integrand. So what do you mean by dx again? Again, like a previously you brought it. What do you mean by dx? Can you say anything about dx? So dx is, it represents an infinitesimally small place of the independent variable, small place or anything, a small value also you can write it, of independent variable x to be multiplied by the integrand and summed up in an infinite sense. The dx is, I think, what all that diagram, no, that only as I just put in the form of a sentence. So what do this I indicates area under the curve. This is the primary thing over. Okay, now you got like, so I want area under the curve from x equal to a to x equal to b. That is what this will become lower and upper limit. And what is f of x? F of x is y. How the curve y equal to x square, y equal to x, that you are going to substitute. Then integration. Hope everyone is able to understand. Sir, how do you integrate? Okay, this will go for the power rule. The first power rule, what it says is I equal to f of x dx, where f of x, let it be equal to x to power of n. The first is the power rule is what we are putting it. So what is f of x? F of x equal to x to power of n. Limit, let me substitute the limit also, a to b. Then this will become integral I is equal to f of x is xn dx a to b. What is the value of integral value of this one? It's given by the formula x to power of n plus 1 by n plus 1 with the lower limit and upper limit. Further, this 1 by n plus 1, keep it like it is. Now substitute upper and lower limit. So this should become equal to I equal to 1 by n plus 1, x to power of b to power of n minus 1, a to power of n minus 1. Okay, this is called like a definite integral. So what is a definite integral? Where it will be bounded. The function will be bounded by a values here. The function will be bounded by a values. Function will be bounded by a values here. So definitely definite integral leads to a value. I'll write it. I'll write a comment. Definite integral leads to a value. Okay, sir, like, can you really find out area under the curve because you brought a formula? Okay, let's try. Let's try. What is there in that one? So I'll start with the discussion like this. Okay, we'll try to end up everything in this page. No.